Hello, I'm Dr. Papia Bhattacharjee. Okay, in this problem, this is a fun problem. We will have to determine the value of this constant a, which is not given. And we have to figure out what is the value of a so that the function will be continuous everywhere. That means on the entire real line. So f is continuous. All right, before we try to solve the problem, let me remind you the definition of continuity. So what does it mean by function is continuous at a point, and say the point is C. So the definition is that the function value at C should be equal to the limit of the function as x approaches C. Now notice that when we write this equation, we are also assuming on top of that f of c has to be defined. So c is actually in the domain of the function. The limit has to exist, so it has a value, and the two values are equal. Now for this particular problem, let me break this definition up a little bit more. This is equivalent to saying that f of c should be equal to the limit, but remember, what does it mean by a limit to exist? That means the left hand limit and the right hand limit should exist, and they should be equal to each other. So I'm just breaking up this part and writing it a little bit more elaborately, that x approaching to c from minus and the limit x approaching to c plus should also be equal to each other. And that's the part that we will use to solve this problem. Okay, let's take a look at the expression of this function one more time and try to understand why we're even talking about the discontinuity of the function. Can this function have a discontinuity? Isn't it always continuous? Okay, so notice that this function is defined in two steps. And the first part says for every x less than or equal to 2, the function looks like x cubed. So if we divide the entire real line into two parts, everything up to 2 and then 2 to infinity, so the left hand side the function looks like x cubed, and that is a polynomial. So the function is definitely continuous everywhere up to 2. On the right hand side, when x is greater than 2, the function looks like some constant times x squared. Again, that will be a polynomial, and therefore it is continuous everywhere. And in particular, it will be continuous to the right hand side of 2. So the only problem is we don't know what is happening at 2. Can it happen that this polynomial comes and breaks up and then another polynomial starts at 2? And that's why this function may have a discontinuity at this point x equals 2. So we have to figure out for which a that will not happen, that the function will keep on going continuously. So how do we do that? So look here, let's take this particular equation or chain of equations. In order for function to be continuous, so here is what we want. We want f continuous at 2, because that is the only point where the function may break, and we don't want that to happen. We want it to be continuous. For that to happen, we need f of 2, because our c is 2, should be equal to the limit of our function as x approaches to 2 from negative, from the left hand side. Those two should be equal and should be equal to limit of the function as x approaches 2 from the right-hand side. So we basically have, three equations. So why don't we take two of them, the appropriate ones that will help us figure out the value of a. Okay, so let's see if we can figure out what is f of 2. Is it defined? Well, it is said here that when x is equal to 2, f of x is x cubed. So definitely this value is 2 cubed because you're plugging in 2 in x cubed. Okay, what about this limit? So let's try to understand it a little bit more. We want limit as x approaches 2 from left side. Left side means x is picking values smaller than 2. So x is picking values smaller than 2. And therefore, the function expression should be this one. We are considering x cubed here because x less than 2 means the function behaves like x cubed. What about this side, the last one? Here we are considering the limit as x approaches 2 from the right-hand side, which means x will pick values that are greater than 2. And then we will be considering the bottom expression of the function for this particular limit. So f of x is then ax squared. So those are all three things. Now let's see which ones we want. Well, these two together won't really give us our answer because there is no a anywhere. But this one has a. So why don't we take this limit and this constant, set it equal to each other. So we want 2 cubed to be equal to the limit ax squared as x approaches 2 from right-hand side. So this is 8. And let's see how to calculate this limit. Well, a is a constant. You know the property of limit. You can pull the constant outside the limit. And then you just have to evaluate limit of x squared as x approaches 2 from right. Now this is a polynomial. X squared is a polynomial. So to evaluate the limit, we can just do a direct substitution. So 8 is equal to a times. So directly substitute x equals 2, we get 2 squared. So 8 is equal to 4a, and therefore by dividing by 4 both sides, we get the value of a. So this gives a is equal to 2. So last time, if we write down a equals 2, so the function is defined as 2x squared for x greater than 2, then this function will be continuous on the whole real line. Thank you.